All right, who knows what probability is? Who kind of has an idea? What's probability? What in the world does that even mean? What's the chance that one of you knows that probability is? Josh?
Sort of like a likelihood or something.
Good. It's a likelihood that something an event will happen. I'm going to put it like this: probability. So to give us a little definition. And honestly, I think you guys have an idea, but it's harder to put into words. We're going to call it is the chance some event will occur. Or some event will happen. You're like, what event? Well, it depends on what you're trying to figure out. What's a probability that we use often? Even just like today, you may have looked at.
Gambling.
Rain, weather, gambling. People use it for probability. Sports, like your brackets. Some of them are broken. The probability failed you, right? Actually, what happens is with probability, what it is us taking things that could happen, like rain, based on the weather conditions, pressure, temperature, all that kind of stuff. You can predict if it's going to rain today. Now, are they always right?
No. Usually they're not.
But I would say that it is helpful to know at least what the probability is, because as you walk out the door, you're like, it's a 70% chance of rain. You might want to get prepared for that. Snow, is that important to be prepared for? Yeah, like today, 0% chances of snow. I'm not bringing my winter coat. I don't have to worry about my scraper. I just really have to worry more about rain or sunshine. Which, does sunshine affect your driving, by the way?
Yes.
Really? What? It makes everything bright. You can see everything. It can shine in your eyes, so you want to be prepared for that as well. But probability is the chance that some event will happen. We see it with weather, sports. Yes, people use it for gambling. That's not the point of today's lesson. But what I want you to know is probability, simple probability, can be stated in a ratio. Now, that was a long time ago. That was last week when we talked about a ratio. Who can tell me what a ratio is? Peter?
It's stated X, comma, Y.
Oh, okay, so you're thinking of like a ordered pair? Okay, you're thinking of points on, you're thinking exactly that, points on a graph. But what's a ratio? Which you can use those as a ratio. Cole?
Comparison of two numbers by division.
Yeah, it's just a comparison of two numbers, okay? Now, in probability, you're also comparing two numbers that are stated as values. So the two comparisons are, or the two numbers being compared, the number of favorable outcomes would be in the numerator. Number of favorable outcomes. And it depends on what outcome you're trying to look for or measure. So the number of favorable outcomes, that's going to be a certain value. And on the bottom, the number you're comparing it to is the number of possible outcomes. Those are the two values you're going to be comparing. And that's a ratio, and in this case, a specific ratio called probability. Okay? Get that down. This is important. This is the key to the lesson. If you don't know it, it's very hard to do it successfully. Okay. Once you get that down, we're going to look at some simple probabilities. Can someone read for me example number 1, please? Example 1, 440. Okay, Murphy, read example number 1.
What is the probability that you will roll an even number when you roll a number cube?
Okay, a number cube. We don't call them that very often. We call them a die, which is singular for dice. So if you have one or more, or excuse me, two or more, it's dice. If you have one of them, it's called a die. So I'm going to write this down here. This is kind of extra, but it is important, especially with later probability. That's a brace. And what are the different outcomes when you roll one number cube or one die? Just a normal number die. What are the actual outcomes that you can get? 1, 2, 3, 4, 5, and 6. And you guys either who have taken Board Game Designer are in it, you guys realize that, right? You have 2, I think, number cubes with settlers. I haven't played that in a while. But you have two of them, and your possible outcomes are 1, 2, 3, 4, 5, 6, and that's if you have one, okay? That's one die. Okay, we call this right here the listing out of your possible outcomes. We call it sample space. So if you ever see that later on, you're like, those are the actual possible outcomes you can have, in this case with a number cube or a die. Okay, we said probability of getting an even number. Oh, are you giving me the answer? Okay, hold on that. We call it the probability of getting an even number. So what do you think this big letter P stands for? Probability. And in parentheses is what you're looking for. What event? In this case, even. We're getting an even number. Okay, it's a ratio. How many possible outcomes? How many possible outcomes? Give me your number of fingers. Just lift up the number of fingers. So like if you think 2, 3, 4. By the way, my son Ezra, he's getting better at that. 1. He does that. He does that. So give me how many possible outcomes you have. Anyone? For a number cube, okay. Okay, I see two numbers. Two numbers. But the actual number is, there's 6. Right? Can't you get a 1, 2, 3, 4, 5, or 6? Yeah. Those are the number of possible outcomes. How many of those possible outcomes will get you an even number? There you go. Yep, 3. You can get a 2, a 4, or a 6. That's 3 of them. And probabilities are always simplified, so what do you do with that 3, 6? Yeah, your final answer should be 1/2. That's your probability. 1/2. Yeah, unless you do something to change that unfairly, it's going to be 1/2. What do you guys think of that probability? Think it's going to happen, not happen? What do you think? It's a 50-50 chance, isn't it? You're going to get even 50% of the time, odd 50% of the time. But does it always happen that way? Oh, have you ever played with those other people who they seem to get those least likely numbers at the right time? Or are you one of those people who seem to get the least likely numbers at the right time? Right. Well, I'm not like you. This reminds me of a game. My son and I, we have this game. It's called Sneaky Squirrel or something. It's very simple, and it's good for him to just learn just different outcomes. It just has a spinner. You're supposed to spin it, and then you have to get a acorn with the squirrel, and he likes it because you get to pick up with the acorns with the squirrel. And there's this one bad thing about it. The last time I played with him, weeks ago. No, I just spun it, and I got 2 acorns. I spun it again, I took his acorns. He either lost acorns, lost a turn, or did not get an acorn. And after that third time, this is how he reacted. I'll never forget it. He spins it, and I said, "Oh, I'm sorry, Ezra, you lost." I forget what it was, but something bad happened. He just put his head down. I'm like, so what I did, as a good father, I took the materials for Sneaky Squirrel, or whatever that game is, packed it up, walked outside. No. I kept it. I'm just not playing it for a while. But he does need to learn how to lose, by the way. Like, I need to learn how to lose, because even myself as an adult, I struggle with losing. But the thing is this. Did I do anything when I... Like, is there a certain technique other than, like, nudging the spinner? Is there really anything I do to make that spinner go or where I want it to? No, he doesn't. Yeah, the force. Which is funny because the last class one person mentioned the force. Which now you are communicating and congratulating each other on that. But I would say this. That seems random, doesn't it? Like, I spun it. Yes, I got 2. Or I lost my turn. So it seems random. Maybe it is, maybe it's not. We'll talk more about that. Let's look at page 442, and I want to see if we can get some other probabilities. I'm looking at number 7. Can someone read to me what number 7 is asking me for? Sarah Curtis.
State the probability of each outcome. Randomly turn to a month in the calendar, and it is June.
Okay, so you're not like looking toward the front of the calendar or the back. You just randomly pick a month out of the calendar and you get a June. So how many possible outcomes are there? How many are going to be June? One. Okay? Can you reduce that anymore?
Nope.
And someone in the other class did this. Does anyone know what percent that would be? How do you figure it out? That's a great question. You do 1 divided by 12. Can anyone do that? Oh, someone did it. They just did it, and they're like, "Oh, it's this." And I'm like, "Yeah, that's actually it." I think it's 8.2%. Is that what you said? Oh, okay. It's about 8.2%. What do you think? What's the probability of getting June when you just randomly, not like I'm gonna? It's about 8.2%. Okay, so not super high. Would you say it's not that high? It's possible, but not high. Okay, let's do another one here. Number 8. Someone read that problem for me, please. Peter? A 3 is rolled on a die. All right, how many possible outcomes do you have on a die? 6. How many are going to give you a favorable outcome of 3? 1. Can you reduce that anymore? No. Does anyone know what the probability of getting a 3 with a die in percentage? Okay, it's 16%. How'd you get that? Okay, if that's 8%, this right here is half of that, by the way. So you just double it. You get about 16%, 17%. Okay, number 12. I'll put it up here. Number 12. Read that one. Oh, excuse me, not number 12. Let's go with number 9. I skipped number 9. Can someone read those instructions, though? Because that's different than the other 2 problems. Nick, read that bold type, please.
A spinner like the one at the right is used in a...
Hold on. I'm getting some bad memories of Scaredy or Sneaky Squirrel. Can you give me a little bit of time? Okay, go ahead. Keep going.
Okay, determine the probability of spinning. Each outcome of the spinner is equally likely to land on each section.
Okay, and they're giving you a very important clause there. If the spinner is equally likely to land on each section. So we're not talking about like on a slant or you weighted something no, it's just equally likely, it's fair. So number 9, what's your probability of getting a 4? How many possible outcomes, Rachel, are there on that spinner? Possible. 8. How many are favorable, are going to give you a 4? Scout? 1. So what's your probability of getting a 4? 1 out of 8, or 1/8, which is about what percent? Good, 12%. About 12%. Wow. 12.5, so 12, 13%. Good. Okay. Guys good on that? Let's do the next one, which is number 12. I want to go to number 12. What's the probability of getting a 2 or a 4? Now, the word or means something. Josh? How'd you get 1/4? I got 2 8s. Oh, okay. Which is what percent? 25%? Okay, 25%. Now, do you notice it said of getting a 2 or a 4? Is that how it stated it? So how many are going to give you 2 or a 4? Out of how many?
8.
And then you can simplify that to 1/4, which is 25%. What do you think of that probability? It's better than the other ones, right? But still not certain. Still not always going to happen. 13. Not a 3. Wow, that's awkwardly stated. Not a 3. So how many possible outcomes, everyone? Possible outcomes. 8 possible outcomes. Like you have 8 sections. How many are going to give you an outcome that is not a 3? 7, because there's only 1 3 there. Can you reduce that anymore? No. That's it. Is that high, low? What do you think? About middle? It's very high, right? Of not getting a 3, it's very high. And then on your own, I want you to do number 14, see what you get. 14, less than a 6. Less than a 6. And what you want to do here is once you get your answer, your fraction, compare with the person next to you. And Sarah, you can compare with Mandy and Josh, and then Nick with those two. And then, yeah, Jake with those two in front of you.
It says less than 6.
Less than a 6. And that the words mean exactly what it's saying. It cannot be a 6. Okay, let's go with Laura. Number, what is this, 14? Number 14. Laura, how many possible answers or how many possibilities do you have? 8. So possible outcomes right there. And Alyssa, how many are favorable for for getting a number that's less than 6? 5 of them. Can I make that any more reduced or simplified? No, that's your answer. 5/8. Do the words matter in these problems? They do. How many of you think this is it's pretty basic, right? Good, because it's time to move on. Example number 2. Someone read that for me, please. It's going to get slightly difficult on this one. Okay, Peter, go ahead. Example 2.
In the game of backgammon, you get to roll again if you roll doubles. What is the probability of rolling doubles?
Thankfully, they gave us a chart. They gave you a chart of all the possible outcomes you can get when you roll 2 dice, and then they gave you the number of doubles. So, I'm going to click that. Cole, how many are going to give you doubles? How many favorable outcomes? 6 of them. Mandy, how many possible outcomes when rolling 2 dice?
24.
Look at the chart. You can look at it. That'll help you out. And then we'll go with Davis. 36 of them. You have 36 different possibilities. Is that my final answer? No, because what can both numbers be divided by? 6. So you should get 1/6 is your probability of getting doubles.
36 out there. That's because
36
options.
Yeah, so you actually have 36 different possibilities, and 6 of them will be doubles. So what's your probability of getting doubles? Is it high, low, medium? What do you think?
Low.
It's semi-low, but it's not as low as I thought. I mean, 1/6 or 1 out of 6, I mean, that's not bad. It happens, and again, maybe you've played against someone who does that, or you tend to do that. Someone actually in the other class, they actually said this. Mr. A, I think I can make it higher. I'm like, oh, really? Yeah, there's a certain way to roll it. Yeah. Yeah. Does he? Okay.
Yeah, like he starts on a number, and then when you roll it, it goes to that number.
Oh, Jensen, I got to figure this out.
He doesn't like this out.
No, he's a wizard. He puts glue on the opposite. Like if the 6 was here, he puts glue on one secret.
So like if he starts on a 6, and he rolls it like forwards, then I'll write it on the 6. Yeah.
You start with you do like that.
You start on the.
I'm gonna have to teach. I have to teach a lesson about Jensen's probability. That's later on, so that's different. That's totally different. Okay, example number 3. This is where it gets a lot tougher. In a popular word game, Scrabble. They couldn't use Scrabble, so they just said in a popular word game. Each player chooses 7 tiles. The 100 tiles are in the distribution shown at the right. Okay, you see that little chart back there? I'm going to see if you guys can interpret it. What it's saying is that there are 100 tiles, 100 different tiles, and they all have different letters. How many D's are there? How many D's are there? D's, the letter D. 4 of them. You guys see where the letter D is on the letter side? And then 4, number of tiles. How many A's are there? 9. Do you see where A is down there? There are 9 tiles. How many blanks? 2 of them. How many Q's? 1. Okay, do you guys get how to read that chart? Because you need that. Blank is on the second. Yeah, blank, which are nice. Okay. Who can read me A on this one? Who can read 3A? Peter, go ahead. Okay, I want to get an E. So if I reach into that little pouch, I want to get an E. How many total possibilities are there? 100 of them. There are 100 different tiles. How many E's? How many are favorable? 12 of them. 12 over 100, or 12 out of 100, which can be simplified into, well, what's it? Yeah, Cole? Yeah, because 4 goes into both of them, you get 3/25.
Wait, where did the 100 come from?
How many tiles are there total? If you look in the bold type, it says there are 100 tiles are in the distribution shown. Okay, so 3 out of 25. Pretty low? It's not bad, but it's not definitely something you're going to have to get. B, who can read B for me? I'll go with Betsy. Can you read B?
An M if 28 tiles have been chosen, and one of them was an M.
Okay, those words mean something. So, can somebody tell me how many tiles are possible?
72.
Why 72? Wait. Oh, weren't there 100 and now 28 have been taken away? So 72 left over. That's how many possible. And then how many M's are there? If you read the question properly, you should be okay, Josh. Wait, it says 2 there. Yes, it says, so there are 2 of them, but it says one of them has already been taken, so you only have 1 left. What's your probability of getting an M in that game at this point? 1/72nd or 1 over 72? What do you think about the probability there?
Very low.
You're not getting that M. I mean, you could, right? You can get on that first try. I got the MC, Mr. A. Probabilities, they're wrong.
So are we Mr.
We're all in this. We're playing this big game of Scrabble. Okay, and C. Can someone read for me? Can someone read C for me? Oh, okay, Sarah? Curtis?
An X if 42 tiles have been chosen, and one of them was X.
All right, how many possible outcomes are there now? So you still start at 100. Now you have 42 taken away. 58. How many are going to give you an X? There are 2 possible answers that you're going to give me. It's either 1 or 0. Wait, 0? How can that be? Oh, there was 1 X, but wasn't it already taken? So how many favorable outcomes? What's my probability there? It's 0, and I'll box it in. That's my probability. You know what that means? It's not going to happen. You will not get an X tile. You cannot get an X tile no matter how much you reach, no matter what technique you use. I pick it with my pointer and lift it up with my middle finger. Nope, not an X, because there are no more X's. If you have a probability of 0, it will not happen. Do you understand that? No? Yes? Yeah? Okay, here we go. Let's get this last chart here. See if you guys understand what I'm doing. Okay, I'm going to draw a little spectrum, which in this case is just a number line. And yes, spectrum. Between 0 all the way to 1. That's our spectrum, 0 to 1. And right in the middle there is, yeah, good, 1/2. Right in the middle. Okay, all your probability answers will fall between 0 and 1. All of them. Every single one of them. If you get a probability of 0, what does that mean practically? What does that mean practically? We call it impossible. Like, you can say it will not happen.
What is the negative chance?
So, great question. Like what about -1/12? Is there a possibility of getting a negative? No. It says it's either impossible or negative impossible. No, it is impossible. It will not happen. Anything beyond that, that is not possible, I guess you could say. Okay, if there's a probability of 1, what does that mean? Okay, yes, I heard the word certain. It will happen. 100%. It will happen. So here's a scenario. I'm playing a board game, and all I need on 1 die is a number greater than 0. So you do your secret, you switch out the die here, throw it, what's going to happen? Yeah, you roll a 0 magically. It's certain. Yeah, Jensen does something and your dice gets -1. And somebody will say, well, Mr. A, what if you're trying to get a number greater than 0 and the die falls off? you know what you do? It doesn't count, or you could say whatever it lands on. Mr. A, what if it lands on its side? See? Then you re-roll it. That's all. And it's probably not a fair die if it did that. Or it got stuck in a gap and you just re-roll it. What about half? What's the probability of half? We call that a 50-50 chance. 50-50 chance. It could happen, it might not. Evenly split. So getting an even number when rolling one die, what's the probability there? It's 50-50. You may get it, 50% of the time you will, 50% you won't. Okay, I already brought this up, and I'm going to close out with this here. Some people seem to be doing getting an even number, like it's certain to them, like it will happen. Some people, they just never get it. It never happens. Whatever they wanted, it doesn't happen. But this is from our perspective. This is from me, Mr. A. And that's why Mr. A doesn't play very many board games anymore, because Mr. A doesn't like the probabilities.
You can come to board game design.
I might drop in one. I'll bring my own. Can I bring my own dice?
We're making our own board game. We're all making a Fortnite board game.
Oh, wow. Yes, ma'am. Question. Okay, sorry, I have a question. Yep.
At the end of time, could you calculate how a game will end? Like, could you?
Yeah, you can get a probability, and that's actually, by the way, like your brackets, there is a probability you can get them all right. The probability, I think Mr. Thomas gave that number, is like 1 in 72 trillion or quintillion. So is it? Yeah, it depends on what you answered. Some guy's offering, I think, $1 million every year for life. You know why he can do that? Because it's not gonna. But if it did, well, he's rich and he can do that. But it's not gonna happen. Not gonna happen. But they can calculate that using all these different numbers. Or I can calculate how many of you are going to get this lesson. How many of you are going to get 100%? It takes me so long to do that's not practical for me. But like if I were doing a textbook, I want to know what my percent is going to be for my people getting right, wrong, challenging, whatever. So yeah, you can figure it out. Well, I mean, that's complex probability. But I'm going to tie it up here. This is my perspective. The Lord already knew if it was certain or impossible. He already knew, boom, it's going to happen. You were going to get a 4. And like he cares about a board game, he does. Even the throwing of dice, he is aware of it. He's in control of it. Okay. Anyway, your homework tonight is. Oh, no, not 1 through 16. Here you go. It is 16 to 31, and then 39 to 41. Pages 442 to 443. Hopefully it's not too hard, because once you get the first problem, that should help you on the next problems. You'll see what I mean.
Maybe that's what's the probability of getting the next question right?
Even if you guess, you still have a probability. Like it'd be 1 in a million, depending on how many digits the answer could be. Or if it's a letter, now you added more to it. So there's a problem. So on the first section, they're talking about the marbles, the red, the green, the black, and the blue. And you're selecting it at random, so you're not even looking at it. You're kind of just reaching over and grabbing a marble. What's the probability, number 16, that you got a red? Well, first you have to find out how many possible marbles are there. How many possible outcomes are there? Anyone know? Someone said it, 24 possible outcomes. How many are going to get you red? 5. Yeah, 5 red marbles. There you go. So your probability on number 16 is 5 over 24. No. Just fraction. Did I? Oops.